All right. Well, thank you for coming to the Google Developer Group. I sort of was focused on this, so can I just get a sense, how many Java developers, let's say? So most people. How many Android developers? Okay, a lot. Other people working in, say, Go, one or two. Python, most people. JavaScript, okay. C#, one. All right, I actually have a newfound appreciation for C# myself. Okay, so I'm going to talk to you about Bazel. This is an anagram of Google's internal build tool, Blaze. Another question, how many Google developers, Google employees are there here? There's 2. Okay, cool. So feel free to chime in if I'm getting something wrong, then yeah, or give other perspective on Bazel versus Blaze. So I'm sort of an unlikely candidate to be telling you about Bazel because I'm not a Googler myself. I've never worked for Google. It was really built for large-scale application development. Their code repository, it's a single large monorepo, petabyte type repository, massive scale. I certainly don't represent those characteristics in my own work. I use Bazel for multiple small repositories like an open source developer would. I don't necessarily work with a large team. But I sort of fell in love with the tool, and I got introduced via front-end development. I sort of drank the Kool-Aid on Google's approach to front-end development with closure and protocol buffers and so forth. And I started looking at Bazel, and there was sort of an unmet need for some protocol buffer support, so I started putting together a repository for that. And Bazel is a polyglot build tool, meaning that it's designed to build artifacts in multiple languages. And protocol buffers is designed to generate source files in multiple languages. So it was kind of a cool project for me that taught me a lot because I was able to kind of spider out and learn a lot of different aspects of the tool via that. So just looking at this demo here, this is basically what happens when you type Bazel build and the // ... means recursively select all targets within the workspace and then build all the buildable targets. So this is this rules protobuf repository that I maintain, and it's designed to build protocol buffers in a bunch of different languages, and so there's a bunch of examples. So it's building a server, it's building a client for this gRPC technology in 9 different languages all simultaneously. So it's pretty cool that Bazel can do that, and it's pretty seamless in how it does that. So what's happening here? So the first thing Bazel will do is it looks in the workspace, and it's going to try to figure out, based on what you tell it to build, do I need to grab anything from the internet? Do I need to clone something from GitHub? Do I need to fetch jars from Maven Central? Do I need to grab other artifacts somewhere else? And then it's going to create a action graph of what is the minimal set of things that I can do, and can I parallelize it? Like which things are dependent on others? And so I'll look at, I'll take various subtrees and try to put them on different processors. And then I'm going to compute a cache key, basically a hash key, just like Git does in a way with its sort of a data model. And I'm going to do as little work as possible. Feel free to pipe up with any questions if you have them as we go along. So Bazel, these are sort of some of the things I'm going to talk about. It's sort of mnemonic or adage is fast, correct, choose 2. And I'll add in extensible and expansile, and I'll tell you what that means. So Bazel's fast because, again, it's able to really use a cache well and not redo work if it doesn't have to. For example, tests, if you ask it to test something again, it will see, did anything change in the input of the test? And if not, like, why test it again? Because we know it's going to be right. So skip it. So you always can do incremental builds, and if you have a large repository. not redoing all your tests is obviously a huge time saver. It's correct largely because of this, sort of Merkle tree architecture. It's extensible, meaning that you can write build rules, which we'll look at in this language called Skylark, which is basically like a variant of Python, but a reduced feature set of Python. And expansile. So this is a term that I sort of use to think about, when you start off with your own workspace, your own repository, you have, that space or that set of targets. But you can kind of bolt on or graft on other repositories and use targets in other repositories just like your own. And so you can grow. And so this expansibility of Bazel's universe is a really cool feature that I think is pretty neat. Why care about build tools? One, a couple reasons. One is, maybe you want a job. No, maybe you already have jobs. But Bazel and Buck and Pants, which are very similar in their architecture, are used by an increasing number of large companies, notably Google. Stripe is a big Bazel user. Improbable, Databricks, Braintree, Peloton. Facebook, ex-Googler Michael Bolin, sort of as a hackathon project, started Buck, which kind of is a heavily designed around the architecture of Blaze, as well as Pants, which was started by ex-Googlers who went to Twitter, and it's a Facebook, Twitter Square, Medium, Foursquare, sort of use that. But if you sort of follow the Bazel repository, you see all of these kind of people from all these companies kind of, visiting in, and so it's a dynamic landscape. Open source, the biggest notable open source repository is Tensorflow. So Tensorflow uses Bazel to build. I would say that has not necessarily been something that, if you go on Stack Overflow and you search for Bazel, it's mostly people complaining like, I can't build TensorFlow. And really TensorFlow is the first project, complex project, building multiple architectures, GPUs. It's not an easy problem to solve in anything, and so people are sort of cutting their teeth in TensorFlow, but it's getting better, I think. As well as other projects, Garrett, gRPC, Halide, or a few of them. So I also thought it was interesting, this is an Android conference. I'm not an Android developer myself, so I'm going to fake a little bit through this, but I had some help with some Android developers to prepare the talk. But I thought it was interesting that Jake Wharton, who's obviously a very influential person in the Android space, he filed about like 10,000 commits in the month of November, of course, and then filed only 3 issues, but all 3 issues were in the Bazel repository, which I thought was interesting. I don't know at what level he's using it. He's probably just checking it out. But anyway, a little bit of history. On the first or the middle column, you sort of have dates of some notable build tools. Make, back in 1976 by Stuart Feldman. And then Ant, Maven. Blaze started work in 2006. I think at the time, Google was using a combination of Python scripts to auto-generate make files, to compile C++, maybe Java as well at that time. But anyway, it was not scaling well, and so they started this new project, Blaze, and then that seeded out through time. And again, these ex-Googlers left and have redesigned or reimagined Blaze in Pants and Buck, which are both excellent build tools. And then finally in 2015, Google open sourced Bazel, and you can see some of the releases. The releases are starting to accelerate a little bit. 0.4.1 came out just yesterday, and I think it'll probably be probably a couple of years before it's 1.0 though. It runs well on Linux and Darwin. Windows support just came out. There's a chocolatey package, but I don't know how well it works yet. But it's an important milestone. Bazel does make a few assumptions about your environment. That you have Python, you have GCC, you have JDK 8 or 7, although 7 is pretty much deprecated at this point, and that you have Unixy-like tools that you'd see in a BusyBox, so forth, and that will, I think, make the fact that those assumptions sort of are built on Linux, and so it's going to make the Windows support, I think, a little slower. There is IDE support with Xcode, Eclipse, and IntelliJ. I'll show you the IntelliJ plugin in a little bit, but these are pretty rough, and they are, I think, below the standard, probably what you're used to with your current Android development environment. It has core support for most important statically compiled languages: C++, Java, Objective-C, Go is a popular one. I use the closure tools, and then SAS, blah, 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 blah. You can read the list, but it's increasing. And so if there's a language you don't see, it's actually not that hard to implement language support, so it would be a good open source project to start. To install Bazel, there's a number of different ways. You can get it through package manager, homebrew, apt-get, Chocolatey package, as I mentioned. You can just copy it off of GitHub, and there's an installable shell script. You can clone it from source, and the secret to building Bazel from source is not to use this compile.sh, because if you clone it, you're like, oh, all right, let's run that. That doesn't work. You have to use Bazel to build Bazel. So now you know. And the architecture is client-server, so the client's written in C++, so you don't incur JVM startup every time you type a command. And then there's a resident Java daemon, which is also controlling various master servers, or workers. If you just type Bazel, you'll get a list of commands, but the notable ones are build, run, test, and then query, which can kind of show you what your build graph looks like. Any questions so far? Anything? No? All right, we'll keep going. So here's probably like a minimal Java project. So on the right, you see you only need really 3 files. One is a workspace file that defines the project root. It can be empty. And then you need probably some sort of source file in there to do something. So we have a simple greeter.java, and then a build file, which defines a package. And a package is a sort of partition or subdivision of the workspace that has different visibility rules and blah, blah, blah. And that's where you put rules. And rules are the instructions that describe to Bazel what you want to build. So in the second panel, Java binary, we've named it greeter. And we've named a main class to run, and a list of sources. There's only one source in the list. And then below we say Bazel run example. Well, it should say greeter, sorry. I think I changed something there. So it should say Bazel run. Oh yeah, no, example, yeah, it should say, anyway, the naming's off a little bit, sorry about that. But Bazel will then build the jar and then build a shell script and then run it. So if you want to add an external dependency, then you start putting things in your workspace file. And it's through the workspace file, which is sort of like the main entry port where Bazel always looks first. And then it reads these rules, these repository rules, which tell it, all right, this is an external dependency, and we'll make it available to you if you need it. I won't download it until you need it, but I know it's there. So here we've declared a dependency on JUnit. There's a Maven coordinate there, and there's a SHA-1 value. So Bazel's also pretty nitpicky about security in general. You wouldn't want necessarily some developer or network intrusion to be able to sneak, jars with, malicious code into your project. So by declaring SHA-1 or SHA-256 values on all your artifacts, then you can sort of lock down your build and make sure it's totally hermetic and sealed. So, so we've defined that in the workspace, and then here we have a Java test rule. We've declared a dependency on the Java library rules we saw in the last one, that example/greeter, as well as the JUnit thing. So when I was first learning Basel, I found this target pattern syntax, which is the // or @ names, pretty confusing. Now it's sort of second nature, but we'll talk about that a little bit more later. So here, shown that we do a Bazel test. And so for the first time we run the test, it builds a test jar and runs it, and yay, it passes. And the second time we run it, again, nothing has changed, so it doesn't run it again. It just reports that it passed, but it was from the cache. If you look at, if you say Bazel query, and then this syntax says, all right, tell me the dependencies of this test build rule. And then, there's actually quite a bit going on under the hood. So, if we start looking at that, you say, okay, my test rule, well, I knew that depended on the greeter. Okay, that makes sense. And then that depended on this source file, the greeter Java. That makes sense. It depends on having the presence of a JDK, and then that goes sort of down through these other dependencies. And you ultimately sort of can see the whole JDK dependency chain in your one build rule. So this query is a useful tool to really understand your dependencies. You can say things like, show me reverse dependencies. I have this file. What is using this file? Or show me like any path between two different sets of targets. So it's a sort of a graph language. So it's pretty neat. And then you can pipe the output to. Here I've said, okay, output graph instead of just the normal output, so that's going to use graphviz dot format, and then we pipe that to graphviz and then create an image to create that picture. Any questions? Okay. So these repository rules, again, there's build rules that you put in build files, and there's repository rules that you put in your workspace file or other files that you might load from your workspace that, again, expand Bazel's universe in different ways. So they have different names that kind of describe their functions. Maven jar, get something from Maven Central, or you can specify other Maven servers. HTTP archive, meaning like grab a tarball from the internet somewhere, unpack it, and then there's always this sort of like dual rule, which will probably be merged into one, but this new HTTP archive means that you take, say, a tarball, maybe it just has files in it, and then you can specify the build file for that tarball after it's unpacked to then expose those files as targets for your build. So you can pretty much kind of graft on any type of artifact from the internet. And that's pretty cool because it kind of replaces the need for either checking in things like, for example, in Go, vendoring source files in is a common technique because Go, while an amazing language, has some issues with that. Or you can just check everything into your repository, but then your repository gets large because you're checking in large binaries and so forth. So with these repository rules, you can, basically, without having to check more stuff into your repository, create a much larger sort of space. So if we say, so I'm going to change directory into this output base. Well, let me just say Bazel info. Am I running another rule? No, okay. I'm actually running Gradle as well to sort of compare the two, but all right. So it just restarted the server because I had to log in this computer again. But if I say Bazel info, it tells me a number of the sort of important directories that it's using. So if I cd and then Bazel info out output base, then now I'm dropped into this area where all these external repositories are placed. And so if I look at that, this, for example, the JUnit, there's a workspace file, there's a build file in there, and there's the artifacts that are downloaded. So if I look at the workspace, it's just, fairly simple. If I look at the build file for that, which it created, it exposes a jar file as a jar and as just a plain file. So that's what external repositories look like. So Bazel is actually quite simple, and that's one of the things I like about it, is that Ant was pretty easy to understand. I don't think I ever really understood what Maven was doing. I got through it, but it was always there's a lot of magic that goes on underneath. And I'd say the same as well with Gradle. But with Bazel, you can kind of understand what's actually happening. There's not a lot of magic. And it's fundamentally the matter of Bazel's universe is just files. That's pretty much it. Source files and generated files. And then rules. And a rule is basically a pure function that takes files as input and produces files. And it's all deterministic, meaning that it's all declarative in that all rules, before Bazel does anything, it knows what files are going to be generated, because every rule has to say what kind of files it's going to produce. So it can always see like the full build, whether or not you're actually executing it. So we talked a little about workspaces. So there's either your local workspace or these external workspaces, which you can connect together. And then when you run a command, there's the loading. It used to be 3 separate discrete phases: loading, analysis, and execution. Now the loading and analysis are sort of interwoven. And then there's the execution phase. So this is a workspace. It can be empty, as I mentioned before. You can also load in other repositories that have rules within them. So for example, this is the rules go repository. Here we're saying, all right, let's fetch rules go, and then let's load this file def.bzl. So that's a file that has Python-like syntax in it called Skylark. And then we're going to sort of hoist this Go repository's name into our scope, and then run it, or invoke it. And that will then call other repository rules to then load up all the things that Go needs to do, in addition to, like, for example, downloading the entire Go toolchain and other things that it needs to do. Any questions about so far?
So if you have done it once, can you then turn off the internet and work with the rest of your code, or every time you will need the internet to get the dependencies?
You need the internet at some point, obviously, but you can pre-fetch everything. There's Bazel fetch, and that will fetch all the dependencies for you, and then you can work offline from there. So there's like these fundamental concepts. There's the workspace concept. There's the package concept. So package is defined by the presence of a build file within a directory. And so if I tree out just showing the build files in this rules protobuf, you can see there's a number of different build files. And that's one of the advantages of working with a build tool like Bazel or Buck or Pants, is that you think about your code a little bit differently. Like with a Maven or a Gradle setup, you're kind of like, you do the standard source main Java, source, test Java, and everything's kind of a big glob. And if you want to partition it, then you kind of have to go through the work of, all right, I'm going to make a new POM, and then repeat all this boilerplate code, and then I have to maintain that. I can't really see it well. It's a hindrance to actually breaking your code up into maintainable units. Same with Gradle. You can do that. It's maybe a little easier in Gradle, I would say, but it's still kind of hard to do. But it's really easy to partition your code base in finer grain units. And I think that's probably the biggest win with these kind of build tools, is that if you convert a code base from, say Gradle or Maven to Bazel, you'll see it differently, and you'll see these connections that you will want to break up, and then and it's much more maintainable and testable. So a build rule, like I said, it's a pure function, meaning that its inputs always predict the same outputs, and there aren't any side effects. So when Bazel's running your actions, it does it in a sealed sandbox, meaning that you have to declare upfront what inputs you need and what outputs you're making. And by doing it in a sandbox environment, you have better control, and you're less likely to shoot yourself in the foot at some point. So build rules. This is the label syntax I was talking about. So if you see something that starts with an @ then you know you're talking about an external workspace. So for example, this last one, Bazel run @com GitHub Google protobuf. And these names are a little long. It's sort of like this flattened, underscore delimited, sort of idiomatic way of writing these names. It's saying run the protoc tool. So if I just go on my workstation and I say protoc, that's the protocol buffer compiler, then I get that. Show me the help. When I say Bazel run com GitHub Google protobuf protoc help, it's exactly the same thing. It's just running a different binary that's in that external workspace that we looked at earlier. So you can address binaries and use tools that you've downloaded in your workspace. So here's a list. I'll put this up. You can kind of study this, but I guess the big one to know is like the colon is the package delimiter. So if you're going through the file system, you say like Java example, and then there's a colon, that's the package boundaries. So it means there's a build file there. And so anything after the colon is either one of two things. It's either a name of a rule, or it's a name of a file in that package. And so the slashes can continue after that, but so forth. Does that make sense? Maybe, maybe not. It takes
Show us an example.
Of.
Go back and show us an example of a build file where you're using that.
Yeah. It's a really small. Can I make this bigger? Sorry. I don't know the. Can anyone see that at all? No. Sorry. Can I just. How do I zoom in the whole desktop? I should know the Emacs. There it is. Command for zoom. So here's one example. Okay, so Google Test. I don't know if there's any C++ developers, but Google Test is a great testing framework for C++. So here we're saying, okay, the external workspace, which has been called gtest, and the names are arbitrary. You choose whatever ones you want, although there is an idiom to doing it, meaning there's a convention. In the root of the workspace, meaning the // there is a build file. So there's a package. So this is the root package of that repository. There is a rule called gtest. And it turns out that rule is a CC binary, which defines the gtest framework. And so when you depend on that in a CC test rule, it's just like depending on JUnit, jar, in a way, so forth. When you have a name with a colon in front of it, the colon is optional in this case, that means there's a rule in this same package with that name. So that's this one. And then we're creating a proto library. So basically we're generating a protocol buffer source file. And the source file is, I don't know what just happened. Do I press this local present input again?
Yeah, try press.
There it goes. So there would be a there's a file, this Baz proto, within two subdirectories. So if I wanted to address that file, I would say slash, and then this directory, which is kind of long, but I'll just kind of abbreviate it. Oops. Test slash example, and then colon, because there's a package here, foo bar Baz proto. So that's one way I could name I could address that particular file. I know there's going to be a file created from it. There's going to be other protocol buffer files, so there might be cc.pb that are going to be generated also. I can address those as well. Actually, anyway, not sure if that answered your questions. It takes a little bit of getting used to, I will admit, in terms of the label syntax. So you can also exports. This is a sort of a complex example of using an annotation processor and declaring how to use an annotation processor. So if I wanted to depend on auto value, which is kind of like a framework that allows you just, do anyone use auto value? Okay. But it's, it would just be like using, say, butter knife, it's the same thing. You say at bind, and you say at auto value, and it generates sort of the boilerplate code for immutable, POJO type classes. Anyway, the point of this is to say that when you depend on some rule, Bazel only considers the first order dependencies, meaning that it you don't get all the transitive dependencies below that. So you can say export, and you can kind of bundle up things. So for example, if you depend on this auto value library, then you'll also get auto value, this other thing, which is a jar, and the Tomcat Annotations API, which is a jar also. You also get the exported plugins, so anytime you depend on that, it'll apply those annotation processor. So I wanted to show you, some Android stuff. So I created this Android branch on this rules protobuf, which is basically an example, very simple Android application, which uses protocol buffers and gRPC to talk between client and server, and it uses Bazel's Android support. Not all of the Android support has been open sourced, namely the testing rules and other things. But from what I hear from Android developers within Google, they really someone said I I stay up nights wondering like how I'll develop Android applications if I were not in Google. So I'll have to take him for it since, again, I'm not an Android developer. But here's what you have to do in order to do Android with Bazel. One is you say what SDK you're going to use. So that's a workspace rule called its Android SDK repository. And you give it the path. You tell it what API SDK level you're using. And then to create an Android application, you'd use this Android binary, and there's an Android library rule too. You give it a name. You tell what sources are included in that. We have really just one main activity, and then we also have some protocol buffer stuff that's in there. You say what resource files you want, and then there's this glob utility function. You can glob everything up. It gives you a list of whatever files are in there. You say the manifest, any other dependencies, and then there's these DEX attributes that you can provide to do DEX sharding. So this Android application is super simple. It extends activity. It's got this onCreate, override that sets the content view to our activity main layout, get some buttons, and then we'll have the send message, which basically creates this asynchronous gRPC task to send the value of our text to a gRPC server, get a reply back, and put that up. So the way that you use this, then you use this mobile install command. So the first time you just say mobile install examples hello world Android main, and so it's going to build your application and then dex it all up and do all that, and then it'll see if you have basically just one device connected. If it's just one device, it'll detect that one device and then push it over. And then after that, then you can use this incremental flag. And I would say that the 3 build tools which are good for Android, Gradle, Buck, Bazel, are all sort of using similar techniques to try to make it as fast as possible. Gradle has instant run, and Gradle instant run actually I think has an advantage over Bazel at this point in that it will do hot swapping, and it'll actually swap out running code for you, whereas Bazel has to restart your application at this point. They all create this little stub application, install that, and then side load from there. And I think they all do DEX sharding, but I'm not totally sure. Any questions about that? Do people like their Android build setup? How do people feel about it? Is there anyone willing to share?
Love hate.
What do you love about it, and what do you hate about it?
The things I like about it is the flexibility and the programmability of it. So it does feel like once you learn it, you can do whatever you want. So when you get to non-trivial builds, there's a lot of interesting things you can do with it to consolidate logic, split it up, inject things from CI into it. CI can play with it really well with Gradle.
Mm-hmm.
That was some of the stuff.
Anyone else with opinions they'd be willing to share? No? From what I've told is large-scale development if you have a large Android application, it gets quite slow, and it's kind of hard to deal with. So I think it's worth looking at these tools, which will definitely speed up your build times if you can get it working. There is sort of a very recent, it was just launched like a month or so ago, 2 months ago, this IntelliJ plugin, which also works with Android Studio. So, you just go to Android Studio. I'm not an Android Studio user myself or IntelliJ user, so I was using Emacs, but I do think there's huge productivity gains to be used for, auto-completion, everything else you get with an IDE. So I think IDE support is critical, and I would say it's just not exactly there yet, but it's getting better. So, but this is a plugin, and you can then use Android Studio with Bazel. To actually use it, then you have to create a new file. It's called .bazel project, and what you put in that is a line that says what your SDK platform is, what directories you want exposed, and what targets you want to sort of interact with. And those can be that ... recursive target syntax. And so when you do that, just reload that so it starts from scratch. So if you go to File, Import Bazel Project, then you can kind of select the directory. You choose a method of doing it. It can create one of those files for you if you want. And then you review that. And then it will import that. It kind of queries the Bazel server to kind of get some information, some metadata. And then it will expose various targets. You can run those and employ those. And so if you run a runnable target, then it'll ask you to select a device, and then you go from there. So these are some of the techniques that the Android users are using to be hopefully as fast as possible. One is this concept of an interface jar, which means that if you calculate the public API for a set of Java files, you only will recompile downstream targets if that binary interface changes, meaning that if you change the method signature of a public function, or if you change, you add new methods and so forth. But if all you're doing is, changing print line statements or changing the private, implementation, then those downstream things don't need to be recompiled because there's no need, there's no change. So it computes these interface jars, and then I talked about the sub application, the side loading, some of these other things. But the biggest advantage that I've been told is that really it's much more maintainable. The ability to partition your code into these more fine-grained units makes it much easier to test and much easier to maintain, again, as it scales in size. Alex Humeski, who's kind of the Android expert for the Bazel project, was telling me that they are looking to open source the Android testing rules. They're working on a desugaring tool which works like retrolambda, and they're also working on incremental dexer that will hopefully speed things up significantly. I also just learned of this project. This is more of like a plug, I guess, for Buck than Bazel, but this OKBuck plugin for Gradle, which looks pretty cool. And basically what it does is it looks at your Gradle file, it looks at all the dependencies, it looks at your source files, and it figures out all the dependencies, and it writes out, in that case, the Buck files. But Buck and Bazel are quite similar, so you could certainly do the same thing for Bazel. And then it basically will write all the build files for you, and then you interact, instead of you interacting with Gradle at that point, you interact with Buck through a wrapper, and your builds are much faster. And so it functions as a Gradle plugin. So this looks pretty cool, and I think it's definitely a solid strategy. The biggest, I would say the biggest code base currently, that probably the only one that has simultaneous Buck and Bazel support, is Garrett. So Garrett, as you know, is a code review tool. Many of you probably use it. It's a big project with back-end plugins, a lot of Java code, PolyGarrett, which is the front end, a different front end. that uses Polymer and blah, blah, blah. It's got a lot of things in there, so it's a big project. They initially started with Ant back in the day. Then they were able to ditch that and go to Maven. And then they were able to ditch Maven, and they transitioned to Buck when it first came out in like 2012, 2013, and have been using that until they just made the switch to Bazel. And the reasons for that are several, but the main reasons is that Buck is kind of hard to extend. It's much harder to extend Buck than Bazel, and you also get the full power of Python, which is actually to Turing. So if you have like a full, absolutely Turing complete language that can do anything, make network calls, do anything, you're going to just sort of like come up with solutions that are, opportunistic at the time. And so as you scale and you have multiple developers and you have all these sort of like, workarounds that you're doing, then ultimately you start shooting yourself in the foot. And as your thing grows, then that becomes more likely to do. So actually not giving developers a full language and having a restricted set of features is actually an advantage at scale. And so that they were experiencing that. And also Buck is harder to extend or expand, like I talked about those repository rules that expands Bazel's universe. Buck doesn't have that same concept that I understand. So Skylark is this extension language. It's Python, but you can't do classes. You can't do recursion. You can't do a lot of sort of like the upper level things. Because another reason is that if you are Google and you've got a petabyte repository and there's like a bajillion build files, if you try to load up all those build files and do complex things or do while loops, somewhere, then it's going to blow up at some point. And so, again, the Skylark is intentionally reduced feature set of Python. So I won't necessarily go over this. You'll be able to look at it on the internet, but this is sort of like a work in progress rule that I was just working on the other day. Again, because I got interested in this retro lambda. This is based on someone else's work, but it sort of shows you how you start implementing these rules, and it's kind of like a work in progress, so it shows like where I'm struggling and trying to put in debugging statements and so forth. So you can take a look at that if you're interested. There's a few advanced features which I'll kind of just gloss over. One is, if you're like me and you have multiple projects and they're all using Bazel, then you start, accumulating a lot of artifacts that are in duplicate. And so, like Chuki was like, "Oh, make sure you have enough space on your device to be able to record." And I was like, "Oh man, we're gonna have to delete a bunch of stuff." But so this local repository cache allows you to say, like, of all of your projects, make sure just use one location. Since they're all based on like, a cache key, just everyone share the same one. That actually, has been in Buck for a couple of years, but they're just getting it in Bazel now. So that'll help, but it's not there yet. You can use a distributed cache, and they use Hazelcast for that. So you can you learn more about it on the repository, and they also do distributed execution, which is, I think internally Google has obviously a much more advanced framework to do distributed caching, remote execution, and so forth. But it is available in Bazel as well. I'd like to acknowledge just some of the people in the project. Damien is, I think, the project lead. He is, most of the Bazel team is based out of Munich. And he is really great because he actually responds to emails. Like he's got a billion things on his plate, like multitasking like nobody's business, and he still can respond to like, my email, and so I definitely appreciate that. David Ostrovsky is one of the maintainers of the Garrett project, and so he did a lot of the work of migrating from Buck to Bazel, so he has a lot of insights about that, and he was nice enough to share those thoughts with me. He has his own job. He's not a Googler. He just does it out of his own free will, so huge amount of work. And then Alex Umeski, who is, again, the Android expert for the Bazel project, and he was nice enough to answer some of my questions as well. So with that, that's all I have. I did write this, does anyone know about the GoPresent tool? Like Go has a nice present tool. So you basically write in sort of like this markdownish like language, and then it just creates your presentation, and it's nice and clean and simple. But I prefer to write in Markdown, so I wrote this tool for this project to present in Markdown. So I'll open source that, and so if you're interested in writing your developer presentations in Markdown, then try out my tool, which will come out at some point. So that's what I got. Any questions or comments?
I've been doing a lot of like microservices development with Docker and Kubernetes. I really like the Python syntax. Could it fit in kind of like a Jenkins build process? Is there any?
Yeah, one of my favorite rules in Bazel is this Docker build rule. And so that was, I believe, written by the Google Container Registry people. And what it does, I mean, when you build a Docker container or Docker image, you're basically building a file system, and then all those files have a timestamp associated with them. And so there's all this non-deterministic junk in there. That means that every time, if you change a file, then you basically have to regenerate your Docker image every time. So they wrote basically a Python script which goes through all the files, all the layers in the Docker as you're building it. It strips out all the non-deterministic stuff. So when you build a Docker, you only will rebuild it if any of the inputs change. So it's a deterministic Docker, and it's totally awesome. And I think it's like one of the best well-kept secrets in Bazel. But so you should definitely check that out.
Just to add on top of that, I have a Jenkins server that does Basel builds. So yeah.
On that, are there ways to sort of split up automatically a Bazel build that into independent Jenkins jobs and have that sort of distribute that way, or is it monolithic?
You could, if you had different packages, for example, you could have different Jenkins pieces built with the different packages in turn, so you could do it that way. Because everything has a custom build file, so if you just build rules on your build files, you can split it up however you want.
Sure, but you would need to go and then create the individual Jenkins jobs that are
Right.
calling those individual. There's nothing automatic that says like for every workspace file, create a Jenkins job and then build a graph.
No, not that more.
Okay.
There's a number of Travis build scripts. So you can look at a number of different Travis scripts. And then the Bazel build organization, GitHub organization, has a whole continuous integration repo, which is their Jenkins setup for building Bazel itself. It's a fair amount of code. I wouldn't say it's totally easy just to go through, on an afternoon, but that's certainly there to refer to.
I was looking at the documentation for C++, and it looks like you need to kind of build your own rules based on which header files you're including. Is that your experience, or is there any shortcut there where it can figure out the dependencies and automatically override stuff if certain header files change?
Can you clarify the question for me again?
If you're running make, you can build with GNU and give it an output option that says dump my dependencies out to this file. And that'll dump it out in make format, and then you just include that file. And it'll know that when you touch this header file, well, that's included in 15 C files, so we'll recompile those 15 and not the rest. But it looks like you have to build that dependency yourself in the form of individual rules for every one of the files that are referenced in the C++ build for build options for Bazel. I'm just curious if there's
I'm not like a primary C or C++ developer. So I'll have to punt on that.
I can kind of answer that.
Yeah, be good.
So I do have some C++ rules in my repo too, and yeah, with the C++ libraries, let's say you have a library. So you specify your sources, you saw that in the Java rules, all your Java files. But in the C library ones, it's a little different. You specify your sources and your headers as two different sections. So you say your sources can be all your files, and your headers can be all the files. You didn't touch on it in this presentation, but there's a function called glob, which basically used to say glob and then star.h, and it's suck in all the header files under whatever directory. So you can do that, and that way you don't have to specify. But then that way your C++ library rule knows all of the sources and all the headers. So if you do change a header, it's going to be able to figure out everything that you
Okay, so it will figure out exactly which files you reference.
exactly, yeah. And it won't compile anything else, just it'll use the graph to figure out exactly what it's
Google Protobuf, is one example of, there's boring SSL, there's actually a number of C++ libraries on the internet that are using Bazel, but this is a good one to refer to, if you are interested. These ones are pretty explicit, meaning they're listing all of the individual things independently, and I would say that is sort of like how most people do it. Most people are pretty explicit about naming everything, but you can study this build rule.
I think the main thing I'm trying to understand is like if I change a C file and add a new .header include, should I also be going into a rules file and updating the rule? Or does something do that?
If you glob it, like he said, then it'll pick it up. It'll also scan your headers. You scan your source to make sure that you've actually named all the things you need to name.
C++ library. Sources are all C++ ones.
So, is Google identified this to replace Gradle? Is that where we're going with the Android development environment? Or is this?
I mean, internally they're not. Well, I don't know. I can't say to what degree. Obviously, they recommend Gradle at this point for Android projects. I mean, all of the documentation, all the Android studios, all about Gradle. 2 years from now, I don't know what that'll look like. I certainly can't talk for Google, but I think it's a faster, more scalable way to do things. And Gradle, is a great tool, a great team of people behind it, and it has an awesome community. So I don't think Gradle is going away anytime soon. You may be seeing more of these things like OK Buck, where you can merge the two together and kind of maybe have the best of both worlds. But ultimately, yeah, I mean, if I had to predict it, I would say that this is just a superior family of build tools that's just faster and more efficient. So yeah, I think just from a competitive standpoint, I think probably.
Okay. Are there optimizations that have come over from inside Google to handle really large repositories for this? So if I had 50,000 workspace files in a repo somewhere, can I scan those and cache that, kind of like Gradle is doing with all the build cache?
Yeah, I don't think that would be the limitation. I would think the limitation would be, again, distributed caching and distributed execution if you have like a really huge repository. So like at Stripe or blah blah, they set those things up to support that. So if you're working in a large organization, you're going to need some of those distributed features that aren't just like right out of the box.
Is it every time you invoke the runtime, is it scanning the files, like the the workspace files themselves? Is it reading those on every invocation, or is there some sort of like persistent?
Yeah, it caches. I mean, it caches everything that it can. I would say, yeah, it does. Well, I mean, it reads builds files if they've changed for sure. Does it reread them if they haven't changed? No, I don't think it does. Yeah.
So a little bit more on that. It's a multi-process, like client server, like you said before. So when you load all of your, well, let's say the server's not running. So the server has to run. So you invoke Bazel over a directory. It spawns the server, and it goes and loads and caches everything in memory, so it's all ready to go. So then when you execute another command that doesn't do that, it just sends a message to the server and says, hey, go do this. The server already has it in memory. It's ready to go. So it's super fast.
Yeah.
So the initial, once you run it initially, it has to load all your build files and compute all the graphs and figure everything out. But then once that's done, it's good for pretty much, but it times out after like 8 hours or something, but it's good to go.
Right. So like a no-op build, like nothing has changed, still with Maven would, for a large project, it's going to be like 4 minutes to figure out that it has to do nothing. And Gradle too, for a large project, you're going to spend minutes waiting for tell you to do nothing. So you're going to get up, go. Yeah, that's true. Yeah.
Yeah, it's very similar to the. Yeah.
But yeah, I mean, no-op builds are like instantaneously it'll tell you nothing to do. So back to work. no coffee. Anything else? All right, well, feel free to contact me if you have any questions, and if there's any Android developers who want to help me with my Android development, please help me. So, all right. Well, thank you for listening. Appreciate it.
Thank you.